So this is going to show you how we can find, we can derive the area of a parallelogram from the area of a rectangle. So we know that when we have the area of a rectangle, sometimes people say length times width or base times height. So I did base times height with the B for down here and the height for H for the height. And notice, and this is always the case, that the base and the height meet at a 90-degree angle. So if I take this and I draw a line over here. Let's try again. That's pretty good. Okay, and I take this triangle and I move it over here. Okay, you can see, that's not good, that we get a parallelogram. So I'll draw that down here so we can see it better. Something like that, where we have this line is still there from before. So here we have this base and we have this height. And I haven't actually changed the area of it, right? So I've just taken this triangle that used to be over here and I moved it over here. And so the area of this parallelogram is also base times height, just like it was for the rectangle that we started with. Okay, so the area of a parallelogram is base times height. So now let's look at the area of a triangle. So in a triangle, we have a base and a height. Remember, height is the same as an altitude, and every triangle has 3 different altitudes. So I've just drawn this one here. Again, base and height meet at a 90-degree angle. And we can see here that if I was to draw, if I enclose this triangle in a rectangle, you can see that the base and the height of the triangle are the same as the base and height of this rectangle. And to find the area of a rectangle, we would do base times height. And so that would give us the area of this orange, mostly orange rectangle. But to get the area of the triangle, I need to cut that in half because this triangle takes up half of the rectangle. So the area of a the area of a triangle is base times height divided by 2, or sometimes we say 1/2 the base times the height, right? Those are the same thing. We can do them in any order. I can do 1/2 of B and then multiply by H. I could do 1/2 of H and then multiply by B, or I can do base times height and then divide by 2, okay? And either of that's fine. One thing that I want to remind you again is that every triangle has 3 different heights or 3 different altitudes. And so if we have something like this, the altitude is actually outside, I think that's pretty good, outside the triangle itself, right? So you can see that if I extend this bottom line here, like I did at the bottom, maybe here, let's make it a different color. If I extend the bottom line, okay, so if I extend that side, then it meets this black line that I drew at a 90-degree angle. So now this is the height of that triangle, and this is the base of that triangle. So to get the area of this green triangle, I could take this base times this height and divide by 2. So it's still the same formula, but it's important to recognize that sometimes the height of the triangle is outside the triangle itself. So now let's look at the area of a trapezoid. So in a trapezoid, we have 2 bases, base 1, base 2, and they are parallel to each other. By definition, the bases of a trapezoid have to be parallel. And then we also have a height in a trapezoid that is perpendicular to both of the bases. Okay, so what I did down here is I took that trapezoid that I drew and I just flipped it over. And I can see that if I put it on there, right, now I have what looks like a parallelogram. So I have this trapezoid that we started with, and I copied it and flipped it over. And now you can see that the length of the bottom of this parallelogram is B2 plus B1. And I can see the same thing happens up here. I have B1 plus B2 up here. Okay, so to find the area of this trapezoid, we can remember that to get the area of the whole parallelogram, I would take the base, which is now B1 plus B2, right? That's the whole length of that base of this big parallelogram now. And then I'm going to multiply by the height, and that would be the area of the parallelogram. But I only want the area of this trapezoid, right? That's pretty good, which is half of the area of that parallelogram. So then I divide by 2. So to find the area of a trapezoid, we do base 1 plus base 2 times the height. Oops. And then we can divide by 2, or sometimes we write that as times 1/2. Okay, so either one of these formulas, we've got this one and this one, which are the same, and that's to find the area of a trapezoid. Okay, so let's look at the area of a kite. So we have this kite, and I had drawn the perpendicular diagonals to help me draw the kite. And I want to show you that I could take this rectangle that I took the time to draw correctly before I made the video, and that encloses the kite. So what I see is that this length here at the bottom, I could say is the same as this diagonal, right? So I've got this diagonal is the same length as that, as the bottom of my rectangle, the base of the rectangle, we could say. And then I can see that this length of the rectangle is the same as that diagonal. So I can call this diagonal 2. And to find the area of that rectangle that I have drawn, I would have diagonal 1 times diagonal 2. And I can see that there are kind of 4 sections here. Let's actually make that yellow. So there's this section, and the part that's in the kite is 1/2 of that. There's this section, and the part that's in the kite is 1/2 of that. This section, and the part of that kite is 1/2 of that, and then we can see that the final section, the same thing is true. The part that's in the kite is 1/2 of that, which tells me that the area of my kite is 1/2 of the rectangle that's formed from diagonal 1 times diagonal 2. So if I take the length of diagonal 1 times the length of diagonal 2 in the kite, and then I take half of that, I get the area of a kite.